Hey, how you doing? Okay, I was reminded of this argument today by my friend Arwen. I used to make this argument back in 2016 when I wasn't even debating anyone. I was just a flat earther, a year at that stage, and I used to make this argument on comment sections on YouTube videos. So this is self-evident. It's something at the time that was so simple that it was kind of hand waved away by the Polaris, by the opposition. But now in 2021, it holds a whole lot more weight. Okay, let's get stuck in. All right, Polaris proves it's flat. Polaris can be seen 1 degree, possibly 2 degrees, past the equator line. So that means that Polaris is seen 69 miles beyond the equator line. So 69 miles, 1 degree of distance going by globe Earth geometry, has a drop value of 3,175.04 feet and a hidden value, that's the hidden amount, of 2,904.57 feet for a 6-foot observer height. Globe supporters may say that Polaris is being refracted, right, question mark, but this argument is debunked by the fact that we can see Polaris beyond the distance possible on a globe Earth, due to there not being a geometric horizon in the way. The refractive retort that could be used is based mathematically on the geometric horizon in the first place. As standard terrestrial refraction is based on a radius value that is based on a measurement of a geometric horizon. A geometric horizon that is obviously not there, as if it was, then people could not and would not be able to see Polaris 1 to 2 degrees past the equator line, due to the fact that there would be 2,904.57 feet of Earth obstructing their view. And if globe proponents say that Polaris could be refracted in their model, they are stating that Polaris is being refracted 433 light years away, as that is the distance to Polaris in their model, by refractive calculations that are purely based on a geometric horizon that is not visible and is only mathematical in nature. So is Polaris being refracted 433 light years away by a mathematical belief? No. Okay. This is what's happening with Polaris. This is a sunset and sunrise demonstration, but this is exactly the same thing. It's purely visual, purely optical drop. I'm just going to move that down. As you can see, if you were sailing south north of the equator, this is what Polaris will start to do across the ocean and head towards your horizon. So the further south, due south, directly south you sail, on, let's say, the Atlantic Ocean, then the Polaris will appear to drop. But it's only optical drop. It's only perspective effect. That's all it is. A very necessary one. That's all that's happening. So that's what Polaris is doing. That's what the sun is doing, the moon, all these things. With a few refractive effects added in. Obviously, you have inferior mirages on the sea and other different things happening. But it's the same thing. So I'll show you again. It's a slightly different one. So this is more like a sun, but it's the same thing. If you can imagine, Polaris does the same thing, except for we move. The sun is moving as opposed to us. But when it comes to Polaris, we move and Polaris is stationary in the sky. So it appears to drop. So this would be like if you're going north, north of the equator line, from one point, or even from 1 to 2 degrees south of the equator line, because they can't be seen there, which is the point of the video. And this is what's happening. If we were moving south, north of the equator line, you will see Polaris appearing to drop. There we go. As we move away, it appears to drop, and this will continue happening until you go to 1 to 2 degrees past the equator line. There is some reports that it can be seen further than that, but I know that the general consensus is that it's seen 1 to 2 degrees below the equator line, and even 1 degree is almost 3,000 feet of hidden in the globe Earth mathematics. So that's a complete impossibility. Polaris proves it's flat. Thanks for watching.